Thank you very much for attending Groome's webinar, and welcome to our titled webinar, Value-Driven Inspections, Driving a Positive ROI. Over the past 50 years, Groome has grown with a value-add model. An integral part of this value is a consultative inspection process. This is what we're going to be discussing in detail today. This is Groome's 8th webinar in the series that's presented topics on a variety of subjects over Groome's different divisions. Today's topic applies to many of the services that your plant employs. We're going to provide some specific examples from the power generation industry today to give an example of how wildly different results you can get from different inspections. A little bit on the webinar organization today. We're going to discuss the basics of an inspection program from 30,000 feet. We're going to look at what an inspection program looks like, what you should expect. We're going to look at some examples of a report to give you firsthand perspective of what you kind of want to see to get the inspection findings nice and organized in a report. And also look at some of the inspection deliverables and what you should expect from a successful inspection and project design. Lastly, we're going to look at 3 different cases with wildly different scenarios. And this will be done by design to show you the outcome of these projects. We're going to leave about 30 minutes with room for Q&A after. Please feel free to ask questions in the questions or chat sections. All listeners are muted, so we'll get to your questions as soon as we finish our presentation. A reminder that this presentation is being recorded for future viewing. A little bit on our speakers before we start. My name is Steve Houghton. I'm the VP of Sales at Groome. I work on the sales side with Groome's Hersig, refinery, industrial cleaning, coatings, and door divisions. I also welcome Matt Cohen. He's a newcomer to Groome's team who offers years of value-add experience from the industrial service space. So welcome to the team, Matt.
Thanks, Steve.
Now we're just going to jump right in to perceived value. Before any inspections are done, it's important to understand the desired deliverable from the work itself. This is important because 2 identical units in different states or in different industries, such as power versus refining, are either working with different permit restrictions, or they might be working with different output expectations, such as megawatt output versus steam output. A simple visual here on the left side illustrates revenue gain in the power gen space due to megawatt output, and revenue gain in the refinery space from steam or product output. On the right-hand side, it's more of a story of compliance. Permit restrictions such as ammonia slip might cause some plants with tight compliance to have to derate or have to file for a variance, while similar plants with lenient permitting might only suffer the effect of wasted ammonia and downstream salting, which are both huge problems in their own right. Understanding what scenario your plant falls into can greatly impact the deliverable from your inspection, so you and your inspector are both working towards the same goals. I'm going to pass it to Matt to discuss a little bit more on the inspection process.
Thanks, Steve. Yeah, so where do we start? When it comes to planning during an outage for looking at things that may need attention, there's some options that every plant has. First being plant employee. The positives of that scenario would be that person's already on site. They have firsthand knowledge of the facility and the components that make it up. And cost is beneficial because that person isn't costing any additional money. Downside to that would be that person probably doesn't have the ability to make the repairs necessary to fix any problems. And that person probably isn't a subject matter expert. Second option would be to outsource it to someone like a subject matter expert. Those people also have industry awareness. They probably don't have the potential to repair or fix anything that needs fixing, and it does cost money to have someone like that come in. Third option, which would be the best, would be a partner, someone who kind of checks all the boxes, is a subject matter expert, has industry awareness, can perform necessary repairs, has firsthand knowledge of the components that make up the system, and cost is beneficial due to, at least here at Groome, we don't charge anything to perform our inspections. And we have a lot of experience inspecting units by every OEM. So the ROI, talk about the investment. The motivation to perform any action is driven by a justified reason or a return on an investment. Groome's reason for performing inspections is to create a long-term relationship with its customers that is not just a business relationship, but a partnership. If a customer requires service work following an inspection, Groome can perform the work turnkey, from identifying an issue to designing the solution to performing the work to correct it. Groome can support the entire process from start to finish. While an investment is normally thought about in a monetary way, our inspection process is dependent only upon a customer's investment of time, data, and collaboration. So at Groome, our investment in an inspection would consist of scheduling a time with the plant during an existing or future outage, performing the inspection, analyzing performance or run data from the plant. We generate an inspection report for the customer, and we make recommendations of corrective actions. From the customer standpoint, the investment required would be time to meet with the person performing the inspection, sharing issues or problems that they may have been having, also sharing goals and the future outlook of the plant, sharing the performance data, taking the time to review the inspection report, taking the time to discuss the findings or recommendations that came to light from the report, and taking the time to consider recommendations with their internal team. And as I mentioned before, we do not charge for our inspection process. So, we like to think about our approach as a customer-focused, collaborative approach. A customized approach, no plant is created equal. Different types of plants, whether it be simple cycle, combined cycle, base load, peakers, all with different assets, different turbines, different catalysts. Some have SCRs and COs, others have one or the other, some have none. Ammonia injection grids, vaporizers, boiler tubes, seals, data collection analysis. So it's critical to accurately identify and truly understand issues to make recommendations. We have to understand the current state before making a recommendation. Other things that we're looking at are conversion, ammonia slip, ammonia usage, back pressure, distribution, seals, catalyst frames, and different connection points. So design versus actual. So plants that were designed to run at base load are turning down recently, we're seeing, resulting in detrimental effects that require analysis and flexible solutions that cater to different run profiles. In most cases, catalyst and ammonia systems are designed around a baseload plant. So when not at baseload, these complementing parts of the system have the potential to underperform and cause non-compliance issues. The customer timeline and outlook, it's important understanding the plant future outlook to determine the best solution and when to implement. The long-term solution versus short-term fixes. We need to consider outage time windows versus the impact of the issue. Is it something that needs to be taken care of now, or can it wait if it takes more time to fix? Collaboration with industry expert partners and resources. We collaborate with OEMs, independent laboratories, engineers, and this adds valuable points of view to eliminate missing any relevant ideas that could provide the best solution to a problem. Unbiased solution options. We base these options on science, similar designs, industry knowledge. The options that we present are flexible. It gives a customer the opportunity to decide what solution best fits their need, their schedule, and their budget. In the inspection schedule, every 6 months is what we would recommend. Generally speaking, that's when plants are in outage in the spring and in the fall. And the time to inspect is when the gas path is cool to enter, because you do need to perform the inspection internally. Not every plant has a problem. And for plants that are operating well, an inspection establishes a baseline to compare any changes or damages to down the road.
Fantastic. Thanks, Matt. Great high-level view of the inspection process. Now it's really time to jump into the fun stuff. We're going to introduce 3 different projects, all from the gas turbine space, power plants specifically. All these projects look very different from each other, and that's by design. In the first case, it's a case where the plant had alarms on the SEMS. They knew there were some red flags, but we got a much bigger surprise once we entered the unit. In the second case is a case of emergency compliance management and how the plant handled it with us. And third, not as advertised. This is a great one. It's an ongoing project that Matt's going to give more detail on. And it's a fantastic example of the value of getting a second unbiased opinion.
So case 1, expect the unexpected. This customer was due for catalyst testing and contacted us to have catalyst samples taken. So while the plant was in outage, we conducted a gas path inspection of the CO, the SCR, the ammonia injection grid, and the interior structure of the gas path. So we started at the CO and we ended at the stack. So observations that were made during the inspection at the CO catalyst. The CO catalyst face, as you can see in the picture on the right there, it's clean. The modules appear to be well sealed and fastened to the frame, and we didn't recommend anything being done. It was in great shape. Moving on to the ammonia injection grid, all the observed nozzles were clean. There was no blockage or ammonia salting. The lances, the headers, the supports of the system were all in good condition. Nothing was needed there either. When we moved on to the SCR, this is looking at the upstream side of the SCR, observed modules that were misaligned and shifted, some side to side, back to front. They were missing packing and gasketing. The recommendations that we made were to clean, repack, and restack the SCR bricks within the module, and also repair some side and top seals, which you'll see in the next slide. So this is a example of what a slide in one of our reports would look like. So this is 1 page of a 12-page report. So this is the SCR downstream side. As you can see from the pictures, there's quite a bit of need for repair. So it's blown out packing and gasketing. The side seal pillows had settled and they fell down and ripped. And also the top seal appeared to have gapping, and there was some steel plate hanging down from the ceiling that needed some fixing also. So the plant hired us to perform the repair work. We redesigned the side seals and added some support and some retaining bars to make sure that wouldn't settle or blow out again. Also replaced, added pillows in the top and did some top seal work, as you can see in the picture on the left. We removed all the bricks of the SCR. We cleaned them. We restacked and repacked all the modules, and customer was extremely happy. It came out great.
Perfect. Thanks, Matt. All that firsthand perspective of the inspections and some cutouts from the report itself definitely add perspective. And this is the next level here. We were able to gain minute data from the plant on stack NOx and ammonia slip. And, you know, this data here really shows that the value of minute data itself is tremendous, but the impact of proper data analysis is even bigger. And the example here illustrates what our engineering team plotted from the customer data provided. If you look on both graphs, there's a green line in the middle that shows where the SCR cleaning, pillow, and seal work were completed. Now you can see that the plant ran September and October, and it was called off, didn't run again until after our work was performed. The deliverable on the top stack, on the top graph, is stack NOx. And the improvement there was 0.4 ppm or 17%, solid double-digit performance improvement on stack NOx. But the even bigger win on the bottom graph shows ammonia slip improvement of 33%. I mean, this graph really kind of tells it all, and it's a clear example of total system efficiencies gained when the AIG and SCR systems work together in unison. It's a great deliverable due to successful project design that stemmed from a thorough inspection that was completed by Groome in this case. I'm going to hand it back off to Matt to introduce case 2.
Thanks, Steve. So case 2, emergency compliance. This plant had elevated CO emissions at the stack, and they took an emergency outage. They reached out to us. We rapidly responded to the need. We got in there, we performed a visual inspection, and we pulled a CO sample button for testing. So the results came back and indicated the catalyst was working as it should, which conflicted with the information the plant was getting from their system. So we collaborated with Environex, and we recommended a full system analysis. So instead of just depending upon the results from that single sample, we wanted to understand what's going on across the entire bulk of the catalyst, not just a snapshot. So the bulk samples came back indicating the activity was reduced in the catalyst. So the solution was, we performed a wash study. The results of the wash study showed that an acid wash would bring the catalyst back to a functioning level. So referencing the above graph, so that green line going across is where the compliance level that the catalyst should be offering. So the original button that was first pulled is that top solid orange line, which shows that it was performing as it should. We knew that wasn't a good indication of the entire bulk. So when we pulled the bulk sample, you can see the bottom solid green line, it was just a little bit above 60% conversion. And based on the wash study, you can see the dotted green line at the top was the acid, and it was the best choice. So we performed the acid wash of the entire catalyst bank, removed all the modules, performed that outside the unit, and reinstalled them, and the plant is back in compliance.
Fantastic. This is a great case that illustrates that all tests are not created equal, Matt. The plant was able to make an educated rush judgment based on the findings that they got from the testing and wash study, and avoided major CapEx spend. Everyone knows that steel and precious metals have been cheaper. They're on the rise lately. With that said, the plant saved well over $250,000 versus just replacing the catalyst and not looking at what their options are. Another level of this is just looking at, other tests. A simple test, as opposed to a wash study, would have shown just a few variables, how much life the catalyst had left, platinum load, those sorts of things. The full wash study showed much more, including expected results from different levels of washing, in addition to some of the test result outcomes that Matt went over. So the results always vary in a wash study, something always, worth considering. You might not always need to get the Cadillac of washes. It's worth completing the wash study to understand how your catalyst will react under those expected running conditions. Now on to the exciting project that's still underway. Matt's going to introduce it.
Thanks, Steve. Yeah, so case 3, not as advertised. So our customer had previously received button sample tests from the manufacturer of their SCR catalyst. The results indicated less than 1 year of life left. The plant requested a proposal for installation of the new catalyst to Groome, and another issue that came up during discussion was that they had an issue of accumulated unvaporized ammonia in the ammonia piping. So we thought that it would be a good idea. Customer agreed, took us up on our offer to perform a gas path inspection. For the most part, the components inside the gas path, the catalyst and everything looked fine. There was plugging of the ammonia injection grid that was observed from the lower areas, and so we wanted to make sure that the results were indicative of the entire bulk. What was it really necessary for the plant to perform a catalyst replacement? So we recommended a full system analysis to verify the results they had received previously. And we also recommended a thorough vaporizer inspection to understand what was going on with the unvaporized ammonia. So what happened was the bulk SCR catalyst results came back, and they actually had 3 to 3.5 years left of life instead of 1. Needless to say, the plant was extremely happy about that. And we also scheduled a vaporizer inspection, and we also scheduled an ammonia injection grid cleaning. The inspection also identified areas of significant improvement for both immediate and long-term cost savings, increased efficiency, and upgrades that'll offer ease of maintenance and emissions compliance. Solutions that, the solutions were presented that the plant hadn't considered previously. And I think the most important thing to note with this case is that we opted as Groome to turn down the revenue of performing a catalyst replacement in order to do what was in the best interest of the customer, which has resulted in the creation of a partnership between Groome and this plant. So definitely an investment that I'm sure we'll see a return on in the coming months and years.
That's a good point there, Matt. Short term, as you're kind of leading up to, this plant was able to delay CapEx spend in the 7 figures by up to 3 years. With multiple units, and CapEx expectation or spend $500,000 per unit for replacement. It's well over $1 million in savings that this plant saved and delayed in CapEx that can use that budget elsewhere and plan way more in advance this time around. So huge win, but the savings didn't stop on the catalyst spend itself. The system balance also enabled the plant to utilize the ammonia much more efficiently. This can save a plant $40,000 annually on the ammonia supply alone. Now, the third piece to consider is lower ammonia usage also extends the life of the catalyst. Since this is an ongoing process, it remains to be seen exactly how much more life we can realize from the existing SCR for this plant, but we'll continue to work with them to do just that and get them more life out of their existing asset. At the end of the day, the plant's been empowered to use what they have and work at a high level without spending 7 figures. And that's a huge win and a classic case of working smart. Recap on today's discussion and 4 big takeaways. What to expect from a consultative inspection with industry partners. First off, maximizing the lifespan of SCR. That's what we learned through a few of these cases. You don't need to replace on time intervals. This also applies to CO catalyst. Know what your asset is doing for you prior to shopping a replacement. Just avoid that knee jerk. Second, reducing ammonia usage. A balanced system last year, you can't assume that that system is balanced today as well. Knowing that you have a balanced system is a win-win opportunity for the SCR and ammonia injection grid in regards to lifespan, conversion, and ammonia consumption reduction. Third, increase in power. We illustrated this at the top of the webinar today, but it's more important on the power gen side, but it might be another deliverable such as steam. But either way, minimizing gas path restrictions through the tubes, through the catalyst, mean a better running, more efficient system. And fourth, understanding trends and planning for the future. On-target planning now enables for much easier budgeting and future outages. I want to end on a high note, a very important note. You don't need a long outage to complete a proper inspection. 1 to 2 days down during your short outage, maybe in the fall, gives you time to properly plan for your big outage, your major, or your big turnaround. Next year, next outage season. So take advantage of it and, work with your partners proactively. That sums our presentation up for today. I'm going to open it up to questions and answers. Looks like we've got a few of them. Matt, you touched on this a little bit. I don't know if you can see the question or not, but I'll let you answer it. What's the cost for a HRSG inspection with Groome specifically?
Yeah, so we actually do not charge for the inspection. We do perform repair work ourselves, turnkey. So this is just an investment on our part to show how invested we are in our relationship with our customers.
Perfect. Yeah, this seems to go a long way. It's that unbiased opinion, which is always good. So, another second question here. What areas do you cover for the inspection service? Today, we focused on the power generation industry. I can answer, to that industry specific, on the gas turbine side, and also, more broad spectrum. We offer the same service in industrial coating and cleaning, and also door and mechanical. But for all intents and purposes, to drill down specifically to today's topic, HRSG maintenance and everything from the outlet of the turbine to the stack is where we're looking. We're looking at that gas path, including, duct burners to, perf plates and silencers, ammonia injection grid, vaporizer, and your catalysts, through to your tubes. Groome offers multiple services to clean your tubes effectively, including Kinetic Clean, which is an explosive shot. Now, do you have anything to add there, Matt?
No, I was going to take 3.
Great, all you.
Yeah, so these cases have different turbines that in these different plants. And the question is, do we work on other sized units? We work on there's really no plant that we don't work on. Simple cycle, combined cycle, all the components of the system are taken into consideration, design versus actual, how they're running now. I referenced that in the beginning with, systems are designed, turbines are designed, like an LM6000 is going to run at a certain temperature. And so the catalysts in the gas path are sized and designed to, operate within that temperature range. And that's where we start to see some issues of non-compliance, where the plants are being asked to turn down, resulting in lower gas temperatures, and the catalysts are not performing as they were designed to. So there's really it's not a one size fits all inspection. We consider all the different components, and every case is individual. So.
Yeah, whether your gas path is 10 by 30 or 30 by 80, we've got experience inspecting and working in that space. So looks like that is it for today. Thank you everybody for attending and the great questions. Have a great day.
Thanks everybody.